Hey guys, so welcome back. I am officially back, I guess, to go ahead and review Module 10 with you. It's been quite some time since I've done a video. Honestly, I can't even remember the last time I sat in front of this camera and made a video for you guys. So I'm glad to be back, and I've had a lot of requests from you guys to please make another video to help you guys understand Module 10, and so that's exactly what I'm here to do. I'm going to go ahead and start reviewing with you guys Lesson 10.1. 10.2 and 10.3. It is going to be just kind of like highlights of these lessons. I'm not going to go in full detail. At this point, you should, if you're watching this video, it's because you already have a basic understanding of exponential functions, growth and decay, and geometric sequences. Okay, so like I said, if you are watching this video, it's because you have a general understanding, and what we're going to do now is kind of put the pieces to the puzzle together and do a couple of examples together, and that's basically it. So take out a sheet of paper, some pencil, not some pencils, but a sheet of paper and a pencil, and your calculator also, so that way you guys can go ahead and follow along with me. Do this with me as I'm doing it, because like I've told you guys in the past, you don't learn math by watching it, you learn math by doing it, okay? Math is like a sport, you only get better by practicing. And so if you don't practice and you're just watching me, you're not going to get any better at it. You're not going to know what your mistakes are. So go ahead and, like I said, get a piece of paper and a pencil. Okay, I'm going to flip the camera over, and we're going to go ahead and get into Lesson 10.1, which is exponential functions. All right, so let's go ahead, and I'm going to zoom you guys in. All right, and here we go. I'm letting the camera, there we go, it's focused. Okay, now the first thing I'm going to go into is question number 2 here. It's asking whether or not this is an exponential function. So notice here it says, does this set of ordered pairs satisfy an exponential function? So what you want to do is look at your x values. Okay, how are your x values changing? Are they changing by the same amount? In this case, yes, these x values are increasing by 2. So x values are increasing by 2. By adding 2. Let's be specific here, okay? And now let's go ahead and look at our y values. Now we know that when we are dealing with an exponential function, that our y values have to be increasing or decreasing by the same amount, but not by adding or subtracting. They have to be changing by the same multiplication, basically. Okay, so you have to be multiplying by the same value each time. So how do we know how these are changing? Well, from 4 to 8, you multiply by 2. From 8 to 16, multiply 2. And from 16 to 32, you're also multiplying by 2. So my y values have a common ratio of positive 2. Okay, so this is an exponential function. Okay, now you would do the same thing for question number 3. How are these changing? These are also being increased by 1 if you look at your x values. Now let's look at our y values. Okay, now from 5 to 10, you're multiplying by 2, but from 10 to 15, are you multiplying by anything specific? It's not 2. And from 15 to 20, it's also not being multiplied by 2. So in this case, no, it's not an exponential function. And your reasoning, which I'm not going to write out here, but your reasoning is that you do not have a common ratio. Okay, it is increasing by 5 in the sense of adding 5. Okay, but that would be a linear function and not an exponential function. So those are different. Okay, now let's look at question number 6. And I'm going to zoom in here for you guys. Okay, now I'm going to go ahead and I'm going to transfer this question onto another paper. And then when it comes down to graphing it, I will graph it back onto that same worksheet. So over here, I've told you guys that for exponential functions, you have a times b to the x power. A is your initial value, okay, or your y-intercept. Okay, and I told you guys that in class. and B is your common ratio. Ooh, I spelled that wrong. Okay, so B is your common ratio. So now, for question number 6, we had y is equal to 5 times 2 to the x power. So if I want to graph this, I need to choose x values to substitute into x. But I taught you guys a trick. Okay, and so if I have x and y, okay, and now let me go ahead, I'm going to add another section here. Okay, so I'm going to put my 0 in the middle, and I'm going to do -2, -1, 1, and +2. Now, I've told you guys that your a is your initial value or your y-intercept. What that means is that when your x is 0, okay, that's your a value. So when x is 0, my y is 5. Okay, so whatever a value you have, that's your y-intercept. That's what goes into here. So now these are all being multiplied by 2. So 5 times 2 is 10, and 10 times 2 is 20. Okay, now going backwards, I have 5 divided by 2, okay, which is 2.5. And 2.5 divided by 2 is going to give us, I want to be very specific here. Okay, 1.25. Okay, now I could have done that in my head, but for some reason I was kind of not thinking straight. So, anywho, so now that you have your x and y table, now you can go ahead and graph that on, let me see how I can put it so that you guys can see both the table. Let me fold this. I want to make sure you guys can see the table and the graph at the same time. There we go. Okay, so I'm going to go ahead and I'm going to just plot those points. Sorry, guys. I want to make sure that you can see the graph perfectly. Okay, so now -2 and 1.25, so -1, -2, and then 1.25 is just going to be just above the x-axis. You see how it's literally just above it? Let me kind of zoom you in a little bit. Okay, and so it's just slightly above it, and now -1 and 2.5. Oh, sorry, wait, this was 1.25. That's not going to be there, my bad. It's going to be just above here. I was thinking 0.25. Okay, so over here, this is 1, and then just above the 1 is where you're going to plot that. And then so my next one is -1 and 2.5. So -1 and then 2, and then my 0.5 is going to be over here. And then 0, +5, and then 1 and 10. Now I'm not going to be able to plot this one because obviously it's going to go off the graph, but you have enough points here where you can go ahead and draw your exponential function. Okay, so it's going to go up like this, and then it's not going to go past my x, but it's going to go right about there. Okay, so you get the deal. Okay, now I'm going to go ahead, I'm going to make an x and y table for this, and then you guys can go ahead and figure out how to graph it later. I don't want to spend too much time on this, but for number 7, we have y is equal to -2, and then times 3, and then to the x power. Okay, so again, make an x and y table. And I'm only going to do a couple of points this time. I'll do my 0 here. Doesn't matter where you put your 0 as long as you start with a 0, because this is going to be my y value. So put my -2 wherever my 0 is. And then I multiply -2 each, I'm going to multiply by 3 each time. So -2 times 3 is -6, and -6 times 3 is -18. So now to go backwards from here to get my -1, I want to divide by 3. So I have -2 over 3. Okay? And that's how you would go ahead and do it. Now, just to mention it, if I gave you a function that looks like this, let's say I just have 1.5 to the x power, okay, that means that when I make my table, that means that at my 0, that means that my 0 is 1. Because remember, there's always imaginary 1s everywhere. Okay, so my A value is actually a 1. It's not a 0. It's not that it's not there. It is there. It's just imaginary. So this here, when you have it without an A, that means it's an imaginary 1. So then you would multiply by 1.5, and then multiply 1.5 again, and so on and so forth. Okay? So that is lesson 10.1. Let's go on into growth and decay. Okay, so for growth, you have your initial function. So I'm going to use f of x is equal to your a, which is your initial value, and then you have times 1 plus your r to the t, because remember, it's time that we're dealing with. Okay, now when I have a decay, so this is something that is increasing. Okay, let me put it over here, increasing. So that means that you are increasing at a rate of 2%. You're increasing at a rate of 12%, whatever it might be. Okay, and then your decay is the same formula, but with a minus sign here. So you have f of x is equal to a, and then 1 minus r to the t. Okay, and this has to do with decreasing. Okay, so decrease, decay. Pretty self-explanatory in my opinion. Okay, so let's look over here. So for each student, for each situation, you want to identify whether it's a growth or a decay. And the second part, you're going to actually use the formula to calculate your answer. Okay, so here it says the bird population in a wooded area is decreasing. So this is a decay. And it says by 3% each year from 1,250. So that means it started at 1,250. So this is your A, and this is your percent that you're going to use. So my formula is f of x is equal to 1,250 times 1 minus 0.03, because you want to write it as a function, as a decimal. So you want to do that, and now you want to subtract this because you want to simplify it. So when I'm going to use it in my formula, over here for question 1b, I'm going to have 1250 times 0.97, and it says to find the population after 6 years. So I'm going to substitute a 6 into here. So how I'm going to do this on my calculator is very easy. I'm going to do 0.97 to the 6th power, and then that number I'm going to multiply by 1250. So let me show you my calculator. Okay, so I'm a little bit too zoomed in here. Let me zoom out a little bit. Okay, so in my calculator, I'm going to do 0.97, and then I'm going to use this function here, the y to the x. In some calculators, it's x to the y. So I'm going to use that one, and then I'm going to do to the 6th power because it's 6 years. I'm going to push equals, and then I'm going to do times 1250. Okay, so this is talking population. So I want to round this number to the nearest whole number. So it's going to be approximately 1,041. So my answer here is going to be 1,041 birds. Okay? Let's do the next one. So this says a town's population was 3,800 in 2005 and growing at a rate of 2% every year. So growing. That means it's a growth. Okay, and our function is f of x is equal to my a value, 3800. And then I'm going to do 1 plus 0.02 to the t. So over here, it's going from 2005 to 2025. So that's a 20-year difference. So my formula now is going to be the 3,800, and then I want to do 1.02 because I'm adding, and then to the 20th power. Okay, so again, on my calculator, I'm going to do 1.02 to the 20th power, and then times 3800. Okay, and again, I'm dealing with population, so I need to round to the nearest whole number. So this 0.6 is going to bring this up to a 7. So my answer is 5647. So 5,647. And it's people. Okay, be specific. Okay, so that's an example of growth and an example of decay. Okay, so that's pretty straightforward, I think, for that part. If you have any questions, then of course come see me and I can help you, or leave a comment down below and I can hopefully help you there too. So this is the last section now, and we are dealing with geometric sequences. Okay, now I'm going to stick to using the subscript formulas. Okay, so for subscript formula for sequences, okay, we have a to the n power is equal to a of 1 times r to the n minus 1. So remember, n is your term number. A1 is your first term. And r is your common ratio. Okay, so now over here in my very first example, okay, you see that it says to find the next 3 terms in each geometric sequence. So from 5 to negative 10, how is that changing? It looks like I'm multiplying by 2. From negative 10, by positive 2. From negative 10 to negative 20, I'm multiplying also by positive 2. So my r value is 2. Okay, so my first term is negative 5. Now here, I don't need to use this formula to find the next 3 terms. I just need to multiply by 2 each time. So my next 3 terms, so 1, 2, and 3, okay, I'm going to do negative 40 times 2 is negative 80. Negative 80 times 2 is negative 160. And negative 160 times 2 is negative 320. Okay, so there's nothing more to do there. Okay, that's it. Now, to find number 3, for example, from negative 10 to positive 40, if I do 40 divided by negative 10, so from right to left, I get my r value, which is just negative 4. Okay, so all I have to do is multiply negative 4 each time. So my first term, okay, if I use my calculator, I've got 640 times negative 4, I get 2,560. My second term, I'm going to multiply by negative 4 again, and that gives me 10,240. And then my last term, times 4 again, and you get 40,000. This should have been a negative 2,040 the first time around, sorry. And then over here I get 40,960. Okay, so again, double check those signs. You saw I didn't write my negative sign the first time around. Just double check those signs. It's going negative, positive, so negative, positive, negative again. Okay, so pretty straightforward, I think, to find the next 3 terms. Now, as far as finding the 7th term, the 8th term, the whatever term, okay, that's when you want to go ahead and use your formula. Now, give me one quick second. I'm going to sharpen my pencil. Alright, sorry, it was writing really dull, and my sharpener broke, so I'm just going to get another pencil for a second. Alright, so the first term of a geometric sequence is 6, so that means that your A1 is equal to 6, and your common ratio is negative 8. So I want to find my 7th term. So I have A of 7, because I'm looking for, right here, A of 7, so my 7th term is equal to my A1, which is 6, times my R value, and then my formula says n minus 1, so my n is 7 minus 1 is 6. So I have negative 8 to the 6th power. So negative 8 to the 6th power times 6. So you're going to get one giant number, but that's okay. That's your answer. Okay, so I get 1, 5, 7, 2, 8, 6, 4. So we get 1,572,864. Okay, and it's going to be positive. Okay, so moving on to number 6. My first term is negative 3. My common ratio is 1/2. When I go to find my sixth term, my formula is a of 6 is equal to negative 3 times 1 over 2 to the 5th power, because I have 6 minus 1. Okay, so now I'm going to go ahead and do 1/2 to the 5th power. So I have 1 over 2 to the 5th power times negative 3 gives me negative 0.09375. Okay? So I feel like that's pretty straightforward. There's not a whole lot of confusion there in my opinion. So I hope that this little review helped. If you need anything else, as usual, go ahead and leave a comment in the comment section and I will get it in my email and I could hopefully answer you back. If not, send me an email and I will be more than happy to answer any emails or questions that you guys have. As usual, I hope that this was helpful and I will see you guys in the next video. Have a great one. Bye, guys.